Okay, energy sinks. I'm using this to try and have an interface that we can use between a truck and a car. And we could put an electric vehicle in here. We could put all kinds of stuff in here. But all of those vehicles will have something called consumption. And it is how quickly does the electricity get used up. I'm saying electricity because I'm thinking of one of the later Tesla cars, and they have improved their range. The first time I did this, the Tesla averaged 3 miles per kilowatt hour. And so you had to find out what the kilowatt hour of the battery was, and then you could get the range for the car. Anyway, that's the idea behind energy sync. So I'm going to come into Energy Sync, and we have created one function, public double consumption double CT. Okay, and it's an error because I have yet to return anything of type double. Okay, now the reason it's giving me that error is I put down here open and close curly braces. But up above, this is declared to be an interface, not a class. And the rule I had mentioned earlier was that you cannot declare any method. You can't give a description to any method in an interface. And as soon as I put the curly braces there, that's giving it a method. So this is what it's kicking about. Besides that I didn't return anything, it's the fact that I'm even trying to that it doesn't like. So I'm going to come right there and put a semicolon. Okay, all the little red things went away, but for the simple reason that I'm not defining anything. So this could be an interface. Normally, when you have an interface, that you will have multiple methods. That's the whole idea of an interface. If I declare something to be an energy sink, then I am guaranteeing that I have those methods available. So I can use the energy sink, the interface, to say, you need these functionalities. And so anybody that sees they're working with an energy sink knows they have those functionalities. All right, so that's the general idea behind it. Now let's go do that electric car. Okay, so I'm going to create a new Java class. I'm going to call it electric car. I'm not going to put Tesla there so I don't get sued. Let's see, no, I do not need a public static void main. Click on finish. There's electric car, straighten this up. Now then, here's the thing. I want an electric car to inherit from vehicle, but also meet the requirements of the interface energy sink. Okay, so you can do that, and you put it in here in this order. The electric car extends vehicle, and at the same time it implements the interface called energy sink. Okay, and it's giving, look at all the stuff it's giving me. Oh my goodness. Okay, so let's take a look and see. Okay, energy sink is here, so that's not a problem. Oh, spell implements, that's a problem. Okay, now this is giving me what I'm expecting, because this message will now say electric car must implement start engine from vehicle, and electric car must implement consumption from energy sink. So both of these are now putting requirements on what I must do to inherit from one and implement the other. Okay, so we can just start in here. The first one I'll do is start engine. Doesn't really matter. And as I like to do, I'm going to put override in here. Okay, and this will be public void start engine. Okay, and on this one, keep it fairly simple. All of them have been simple. I'm just going to say turnkey. Okay, that's it. And some of them you don't even have to do that. So sys out, and let's do it this way. Key fob on you. You're good. End of starting car. Okay, now then for the energy sink, which is consumption, again, I'll do an override to make sure that I've spelt it right. I mean, it would give me errors anyway, but this lets me know before I get very far at all that there's a problem, okay? Override, and this is going to be public double consumption. So public double consumption. And I will hand it something. Double. Oh, the mileage. Okay, that's what I'm handing it. Okay, and let's see, end and curly braces. Okay, same thing, it's kicking now because I haven't returned anything of type double. So, like I said, at the time I first created this example, Tesla was getting 3 miles per kilowatt hour. Okay, I don't know what it is now. I know they have improved greatly, but I don't know what it is now. So I'm going to say double amount consumed, get capitalization right, amount consumed is equal to mileage, which I'm given. I better spell that right too on the one up there. It has an E, 2 E's in it. Mileage, and I'm going to take the mileage and divide that by 3.0. I mean, everything else is already double. I may as well be double to start with. Okay, so let me come spell mileage right. Okay, and then I'm going to return the amount consumed. Okay, and let's see, semicolon there, that should make everything amount consumed. Well, I've done something, just a second. Does anybody see it?
Yeah, the first line you spelled it A-N-T.
Ah, thank you. Okay, it makes a difference. All right, so here's the idea. At any point in time, I can go to the car and ask it, how much of your energy supply have you consumed? And depending upon the car, the type of energy that's being consumed, all of that, then you get a response back. But every energy sink has to be able to tell you how much of its energy has been consumed. Now, we'd also want to have in here an energy amount to start with so that we could set the energy amount, get the energy amount, and kind of like, how many gallons do I have left type thing. Okay, so this is implementing an interface. The difference between sugar lump, the difference between abstraction and an interface is that abstraction can go ahead and give you other things. I can give you a default for this, can give you a default for that, just can't give you a default for this. And as a result, you have to declare it as abstract. An interface is really just saying, if somebody implements energy sink, you are guaranteed they have supplied the following functions that you can rely on. And that's why it's called an interface. It lets you know you can call these things and they'll be available to you. Okay, so we'll need to test this one too. Let's see, so let's go back. I'm checking my notes here to make sure I get all the tests in. Test vehicles. Okay, that was that one. That was a biplane. Okay, so let's do a test vehicle and children. Well, this is electric car is a child, so let's see. Okay, so I'm going to come back into test. Let me move electric car over so it's with the other children. Okay. All right, so I've tested the car, I've tested the truck. Now then, I'm just going to copy the truck and paste it and make modifications to it. Okay, so there's the truck. Control C for copy, Control V, paste it right back on itself. So that gives me one, another Control V gives me two. And this is going to be testing electric car object. Yeah, let's see, I need a space there, I think. Okay, so begin that. All right, so now then the type is going to be electric car. Okay. Sorry, y'all, I'm hitting keys I don't mean to be hitting. I turned around and looked behind me. Okay, so let's just change all of this. And it's going to be electric car, and I will call it EC for a name. And that's going to be equal to a new electric car. Okay, happy there. Then I'll do the standard on this ECs. And at this point, I've tested the superclass so much, I wouldn't bother me if I only tested what was new about the electric car here, but that's always dangerous. Test everything. Let's see, let's put the electric car down to 250. Again, those are not accurate, but what the heck, it's something different. Oh, let's go a three-wheeler. Okay, and then we change that, we'll get those again. We need ECs on all of this. Okay, then two more. Okay, now because I inherited from vehicle, it has these functions that I'm testing, but I also implemented the energy sink, and excuse me, it has a consumption method. Okay, so I need to test it as well. Downside to sitting outside, good for my eyes, bad for my lungs. Okay, consumption, so I need to test that. So I'm coming back over. Oh man, it smells like I am just downwind from a campfire. And I'm getting all of that. Okay, so I need to say EC. Let's see, this returns a double, but it prints nothing. So I'll need to put this into a print statement of some kind. Okay, system out println EC dot consumption. Okay, and I must hand it a double of some kind. And let's say we've gone 100, let's keep it divisible, 120 miles, okay? Now then, at the time, it has, well, let's just run it and see what we get. No need to try to figure it out. We're gonna run it and we'll see if we get anything good. Okay, clear all this out. Okay, run. Key fob, not key fog. Okay, typo. 40. Okay, so if it's gone 120 miles, it gets 3 miles per kilowatt hour. It has used up 40 kilowatt hours. Okay, so you better have a battery at least that big to be able to go 120 miles. Let me change the typo right here. key fob on you. You're good. Okay. Try to run that one more time. And it should be the same except for the spelling. Okay. Beep, beep. Yeah, it's an electric car.